Hello, guys. It's Mr. Sanchez here, and I'm coming at you with another Algebra 1 lesson. Okay? Today's lesson is going to be lesson 3-3-3, compound inequalities. Our learning targets for today are going to be to graph compound inequalities and to solve compound inequalities. Okay? Before we begin, we have some vocabulary I want to go over. We have the following words here. We have compound inequality. That is two inequalities joined by the word and or by the word or. So that's pretty much it. It's basically when you have two inequalities put together, and you're either going to use the word and or use the word. If you happen to use the word or and, that's going to give you a conjunction. Conjunctions are compound inequalities joined by the word and. And if you happen to use the word or, that's going to give you a disjunction. So a compound inequality joined by the word or, right? So these are our three keywords: conjunctions, disjunctions, and compound inequality. I want us to be using those words a lot in class, so make sure you get familiar with them. Now, conjunctions and disjunctions are very different types of inequality. So um, they're treated very differently in the way we go over things. And so unfortunately today's gonna be a semi-long video, but we're gonna go ahead and try and do the best that we can and try and get things done as fast as possible, okay? So we're just gonna go ahead and learn everything about conjunctions first, and then we'll come back to disjunctions. So remember, conjunctions, it's a compound inequality joined by the word and. They usually look like this. It's gonna say x is greater than 2 and x is less than 5, right? So that's pretty straightforward. But however, x greater than 2, right? X greater than 2 can be rewritten as 2 is less than x. These two things are the same thing. And so this compound inequality can be rewritten as 2 less than x and x is less than 5, right? Well, this is the same x. And if you take away that end in one of the x's, you can end up being with 2 is less than x and less than 5. So what we say x is between 2 and 5, right? So x is less than 2, but greater than 2, but less than 5, all right? And keep in mind that all these inequalities, you can use the greater than or equal to, less than or equal to symbol. It's going to be the exact same thing, so don't worry about that too much. All right, we'll go over things that we need to as we go forward, right? And so this is a nice inequality here, right? And I like writing my compound inequalities that are conjunctions in this form. So I like writing my conjunctions in this form because it'll make sense a lot more, okay? So how do you graph them? So basically draw a number line, graph each endpoint, and fill the endpoints and fill the area between each endpoint, right? So we're going to be graphing this inequality here. And remember, it was written as x is greater than 2 and x is less than 5, right? So remember, this is going to be open. So we're going to find our 2, and that's going to be open. And we're going to find our 5, and that's also going to be open. Now, if we wanted to graph x is greater than 2, you'd be open and going to the right, right? Because these bigger numbers are bigger than x. And if we're gonna graph x is less than 5, we'd be open and going to the right, right? So that's why I say you fill the area in between. Notice how this arrow is going this way and this arrow is going that way. So they're gonna end up meeting, right? So this whole area is gonna be filled in, right? And the reason why I like my inequality written this way is because it tells you the endpoints here, right? It tells you what it's gonna look like, right? So 2, 2, 5, and 5. And then we're saying x is between 2 and 5. So boom. And we're saying that they're open, right? So that's why we like writing our inequality that way. We're going to have more opportunities to graph compound inequality, right? But it's just the general gist of it, right? You're going to draw a number line. You're going to graph your endpoints. So in this case, it's 2 and 5. And then you're going to fill the area in between. And that's going to make our life easier if you remember that, right? All right, so moving on. That's just how you graph it. Sometimes you're gonna be told to solve this following inequality. So how do we solve? What happens when we have something like this, right? So there's two methods to do this, and each method is fine. Whichever one you want to do is it's really up to you. My preferred method is gonna be method two, but first we're gonna go on with method one, which I call divide and conquer. Okay. So the first method to solve this inequality is you basically split it up. You're gonna rewrite. You're gonna write this part here over here, right? And then you're gonna break this up, this part this way, and write that here, and they're gonna be combined with the word and, right? After you do that, all you gotta do is, oops, what did I do? Oops. Um, After you do that, all you gotta do is solve each inequality on its own, okay? And so let's go ahead and do that, right? So we have 3 is less than 3x minus 6, all right? So we're just gonna get x by itself. So we're gonna do plus 6 to both sides, and you're gonna end up with this. 9 is less than 3x, then you're gonna divide by 3 to both sides, and you're gonna get 3 is less than x, and then you're gonna have to solve this point, right? So you're gonna do plus 6 to both sides. This is gonna give us 3x is less than 14. Then you're gonna divide by 3, and you're gonna get x is less than 14 over 3. But we're gonna rewrite this as a mixed number, so we're gonna have x is less than 4 and 2/3. Okay, but either way is fine. Next up, our goal is to graph it. Remember, it's combined by the word and. So let's just go ahead, draw our number line, right? And then it has 3 and 4. So let's make sure we have at least 1, 2, 3, 4, and 5, right? And then it's 4 and 2/3. We're gonna have this right here: 4 and 1/3, 4 and 2/3. Next up, we want to find our point, right? So this is gonna be open, right? And it's gonna be at 3. And because the x is bigger than 3, we're gonna go to the right. Right, but we're not gonna finish that just yet. We gotta find out where we end, right? So this next one, this is also gonna be open, right? And so we're gonna be an open circle of 4 and 2/3. And we're saying x is less than that. So we're gonna be going to the left. All right, and so you're gonna fill that part in. We're just gonna fill that in. All right. And that's just how you do it. It seems kind of complicated, but it really isn't. All you gotta do is split up your graph, and then you just, when you get x by itself, you just on both sides, you just start plotting the endpoints and then connect it. Remember, conjunctions. I'll write this here. Conjunctions. I am not even putting that. Right. Conjunctions are graphs of conjunctions are line segments. Okay, just remember that. All right. But there is another way to solve this problem, and I think it's the better way to solve the problem. It's my preferred method. But remember, in math you can choose to solve things your own way, and so long as you follow the rules of algebra, everything should be fine. Okay. So let me zoom out and let's go over to method number 2. So method number 2, we decide to solve everything all at once. So for method number 2, what I want you guys to do is draw these dotted lines, right? 2 dotted lines between each inequality symbol. All right. And what I want you guys to pretend is, let's say we didn't have this here. Let's say we didn't have this here. What would you do? What would you do to solve this inequality? You would do plus 6, right? So what we're gonna do is we're gonna do the plus 6, right? We're gonna get x by itself. But unlike before, you see how we have an inequality symbol here and here? What you need to do is whatever you do to the middle, you have to do to the left and to the right, okay? And that's exactly what I want you guys to do. So we're gonna do plus 6 over here to the left side and plus 6 over here on the right side. And then you're gonna evaluate each part, okay? This is gonna go away, and then 3x is gonna stay. 3 plus 6 is gonna be 9. 8 plus 6 is gonna be 14. And then just bring down the inequality symbol like that. Okay. And now to get that x by itself, you want to divide both sides. You want to divide by 3, right? So since we're dividing by 3 here, you're also going to divide by 3 on the left, and you're going to divide by 3 on the right. This cancels out, and you're going to be left with an x in the middle. And then on the right side, 9 divided by 3 is 3. And then 14 divided by 3 is going to be 4 and 2/3. And we know that from the previous section. And this here is going to be your compound inequality. It's just still conjunction. It's just it's going to look in this form. All right. And what I like about this form is that it basically tells you that your graph, all right, and then let me get rid of some of these red points. What I like about this form is that this graph tells you, and then let me just tell you. So there's going to be 2, 3, 4, 5, 6, right? And we're going to find 4 and 1/3, and then 4 and 2/3, right? So what this graph tells you is that it's going to be open at 3, and x is going to be between 4 and 2/3, and it's going to be open at 2/3, and our x is between these two numbers, right? So because our x is in between those two numbers, you're going to fill the area between those two numbers, and that's our graph. And you're going to notice it's going to be the exact same graph here and here. So ta-da! That's why we can say you can use either method you want, whichever method you want. And that's pretty much it for conjunctions. The only other thing that you might see is a conjunction that says x plus 3 is greater than 5 and x minus 2 is less than 11, right? All you gotta do is solve them each individually and then graph each one, and it's the same thing, all right? So don't worry about that too much, all right? So that's all for conjunctions, all right? Now we gotta go over our disjunctions. What are our disjunctions? Well, let's just refresh that real quick. Disjunctions are the compound inequalities joined by the word or. Example, x is less than 5 or x is greater than or equal to 7. Like I said earlier, the inequality symbol doesn't really matter. It can be greater than or equal to. It just depends on the problem. How do you graph these? Well, it's pretty straightforward. Step number 1, you draw a number line, which we already have for us. Step number 2 is graph one of the inequalities. So let's graph x is less than 5, right? X is less than 5. That's going to give us an open circle at 5, right? That's going to be open. And we're saying x is less than, so we want the number smaller than 5. So we're going to go to the left. And let's just shade that in. And this is what x is less than 5. And then step 3 is draw the other inequality. So now we have this, which is closed, right? We have closed circle at 7. And now all we got to do is have numbers bigger than 7. So it's going to be going this direction. So for the most part, disjunctions usually go like this. For the most part, sometimes you'll have special cases. Whenever those special cases arrive, we'll go over them in class together, and then you just have to worry about it. But basically, you just want to draw each graph. Sometimes they're gonna cross each other, sometimes they're not. It doesn't really matter so long as you follow the steps. Okay, if you follow the steps, you'll be safe. All right. So what happens if we get a problem that says solving graph, right? How to solve? Well, if you got a problem like this, it says solving graph. You just got to solve each inequality separately and then graph it. So this is just stuff we're already used to, but just for your old time's sake, we're going to go ahead and solve it. So we're going to have plus 3 to both sides here. You're going to get 2x is less than 10. We're going to divide by 2, and we're going to get x is less than 5. All right, and that's our first inequality, but we're not done. We need or, right? So now we got to get rid of this one by itself, right? So you're going to do plus 4 to both sides, right? So you're going to get 4x is greater than or equal to 24. And then you're going to divide both sides by 4. You're going to get x is going to be greater than or equal to 6. And this is our compound inequalities, okay? And so let's just go ahead and graph this. All right, remember step one, we gotta draw graph one of the inequalities. But let me just put 5 here, 4, 6, 7. All right, and let's go ahead and graph the first one. X is less than 5, so remember this is open. All right, so we're gonna have an open circle at 5, and because X is less than, we're gonna go to our left. And then the next part is X is greater than or equal to 6, so that's closed, right? It's gonna be closed, so we're gonna have a closed circle here. And we want the numbers bigger than 6, so we're gonna go to our right. And I know this was a longer video, guys, but that's basically it. That's all we got to do about disjunctions. Disjunctions, you're going to solve separately and then graph on the same number line. That's basically as simple as it gets. Other than that, if you have any questions, feel free to ask me on the Zoom or email me on Schoology, guys. This has been Mr. Sanchez, and this was lesson 3-3, compound inequalities.